let f of x, y, z equal x cubed times y times z squared plus 4xy squared times z plus y squared times z minus 2y to the fourth times z cubed. Let's find partial of f with respect to x, y, and z. Okay, first let's take the derivative with respect to x. We're going to treat y and z as constants. So the derivative of x cubed is 3x squared, and then multiplied by the constants. The derivative for x is 4, and then multiplied by the constants y squared and z. And then because y squared and z are constants, the derivative of a constant is just 0. And same thing with negative 2y to the fourth times z cubed. Okay, next we're going to y. So let's take the derivative with respect to y now. So x and z are going to be treated as constants. So it's a constant times y. The derivative of a constant times y is just a constant, which in this case is 3x squared times z squared. 4 and the z are constants. The derivative of y squared is 2y. So 4 times 2 is 8, and we'll have 8yz. Finally, we're going to take the derivative with respect to z. X and y are treated as constants. So 3x squared is a constant. The derivative of z squared is 2z. So 3 times 2 is 6. So that's 6x squared times z. And then 8y are constants. So we have a constant times z. The derivative of that is just a constant. And so this is our answer. Next problem. We want to find the directional derivative of the function at point P in the direction of V. Function is f of xy equals x cubed times y, and the point is negative 2 comma 5. The vector v is 3I minus 4j. Okay, the formula that we're going to be using is a gradient of f dotted with v over the length of v. Alright, so first let's find the gradient of f. So this one, you just take the partial derivative first with respect to x. So the derivative of x here is 3x squared. Y is the constant. Now when we take the derivative with respect to y, x cubed is a constant. So you have a constant times y. The derivative of that is just a constant. Next we want to plug in the point negative 2 comma 5 and for x and y. So replace the x with negative 2, the y with 5. Negative 2 squared is 4, times 3 is 12, times 5 is 60, and then negative 2 cubed is negative 8. Okay, so this part is satisfied. Now we want to, let's find v divided by the length of v. V is the vector 3I minus 4j. And here the length of v is going to be 5. And one way, an easy way actually to figure that out is by using Pythagorean triples. So you can think of this as a 3, 4, 5 right triangle. The base is 3. Here technically it's negative 4, but it doesn't matter because you're going to be squaring the negative 4 anyways. So it'll be like, I'll just put negative 4 here. So it'll be 3 squared plus negative 4 squared equals, let's say, c squared. Okay, so you get c squared is 25, c is 5. So if you have the Pythagorean triple memorized, then the length is very easy. So divide both of these by 5. And now finally we're just going to do the dot product. So I can write this as 60I minus 8j. And I'm going to dot that with 3I over 5 minus 4 over 5j. First multiply the 60 and the 3/5. 60 over 5 is 12, times 3 is 36. Negative 8 times negative 4 is 32. and then we're going to divide that by 5. If we add this up together, we get 212 over 5. Our next problem, we want to use the second derivative test to identify any critical points and determine what each critical point is. So the function that we're given is f of xy is x cubed plus y cubed minus 300x minus 75y minus 3. We want to use a second derivative test, so we want to get all second derivatives. First, let's take the derivative with respect to x. That's 3x squared minus 300. Again, let's take it with respect to x. That is 6x. Now let's take the derivative with respect to x and then y. Notice that the derivative with respect to x has no y in it. So you treat this as a constant, and the derivative of a constant is 0. Let's move on to y. Take the derivative now with respect to y. You get 3y squared minus 75. Take the derivative again with respect to y, and now it's 6y. To get the critical points, you want to set the first derivatives equal to 0. In other words, set f with respect to x to 0, and then f with respect to y. So here, the derivative with respect to x is 3x squared minus 100. So you get x squared minus 100 equals 0 by dividing both sides by 3. X squared is 100, and we get x is plus or minus 10. Similarly, f of y is 3y squared minus 75. Set that equal to 0. Divide by 3. Add the 25 over, and then take the square root to get plus or minus 5. So the critical points are going to be in the form plus or minus 10, plus or minus 5. So now we want to use a second derivative test, and let's write out the determinant, or the matrix for it. Okay, so we want to first label all the points. So let's do 10 comma 5 first. Okay, for that we have basically the second derivative with respect to x. So I guess the format's going to be like this. Okay. So the second derivative with respect to x is 6x, but x here is 10. So 6 times 10 is 60. The derivative with respect to x and y is 0, and then y with respect to x is also 0. And then the second derivative of y is 6y. Y here is 5, so that's going to be 30. Okay. So here we get the determinant is 1800, which is greater than 0. And we also have that the second derivative of x is greater than 0, so that means it has to be a local min at 10 comma 5. And if you were to plug it in back into the original equation, so if you were to do f of 10 comma 5, you would get negative 2,253. Okay, the next value we're going to try is negative 10 comma negative 5. So really what changes is the 60 and the 30 become negative now, since you're plugging in negative values. And you still get 1800 as a determinant, but the second derivative with respect to x is less than 0 now. So there you get a local max. And plugging it in to the original, you get 2,247. Now, if I plug in the other two critical points, so we have one positive, the other negative, notice that the determinant is less than 0. Okay, because the idea is you'll get 60, 0, 0, negative 30, and then negative 60, 0, 0, 30. And the determinant for both of these is going to be negative 1800. And when you get the determinant is less than 0, that means you have a saddle point here. So for our answer, this is what we're looking for.